This is the video for the online final exam practice test that covers naming and bonding. When you look at this first example, it says, what is the name for Al2CO3 in parentheses with a 3 outside of the parentheses? When you first look at this, you should be able to pick out that it is ionic. For one thing, it has aluminum, which is a metal, but it also has carbonate, which is a polyatomic ion. So once you figure out that it's ionic, the first thing you should do is go to the periodic table and find the metal. We look for aluminum, and it is right here. Notice there are no numbers in the upper right-hand corner, which means aluminum only has one possible oxidation number, which means we're not going to need Roman numerals or any of that stuff. Compare that to like copper, which could be a +1 or +2. Nickel could be +2 or +3. If it has numbers in the upper right-hand corner, you have to use Roman numerals. Now, it has to be more than one number. Zinc, for example, has only a 2, so that means it can only be +2, or silver can only be +1. It has to be more than one number in the upper right-hand corner. So when you find aluminum and there are no numbers there, that means this question is going to be easier. We don't even really have to look at charges or any of that kind of stuff. You get the name for aluminum. You don't change it. Since it does not have more than one possible oxidation number, we don't need Roman numerals. And then you get the name for the polyatomic ion, which is carbonate. So we get this. Now, we don't use prefixes for this. They're used for covalent compounds. So when we talk about ionic and covalent, what we did earlier in the year, if there was just two elements, for example, in a compound, we would find out the electronegativity of the two elements, and we would subtract the difference. If you got a difference in electronegativity that was greater than 1.9, that means the electrons are being transferred. So it would usually be from the metal, which has a low electronegativity, transferring electrons to the nonmetal, which would have a high electronegativity. And then you're going to get charges, positive and negative charges, so cations and anions. Now, if you do that difference in electronegativity and you got a difference between 0.4 and 1.9, that's telling you that it's polar covalent. The electrons are being shared, but they're not shared equally. So that's when you get a polar compound. And then if you had a difference in electronegativity smaller than 0.4, that was a non-polar covalent compound or bond, which means the electrons are shared equally, right? So you have transferring is ionic, shared unequally is polar covalent, shared equally is non-polar covalent. Now for that one, you didn't even have to do anything with the electronegativities because that polyatomic ion should be a dead giveaway. Plus there was a metal in it. Now this is asking how many lead atoms are in that compound. So really what it's asking you to do is write out the formula. The Roman numeral here is telling you that it's lead 4 because lead could be a +2 or +4. So that's a 4. Sulfate with an ending in ATE, that's telling you that you have to go to the polyatomic ion page, and that is SO4 with a -2. So since this is ionic, what we're going to do is crisscross the oxidation numbers. The reason why we do that is because ionic compounds should end up electrically neutral. The positives and negatives should balance each other out. So now when you're looking at this, though, you have a 2 with the lead, a 4 with the sulfate. You can reduce that 2 and that 4, and you get PbSO4 2. Just remember, if you're working with sulfate, that SO4 has to stay as SO4. You can never reduce that part of it. You reduce the subscript that's outside of the parentheses. And now, like I said, it should end up electrically neutral. There's 2 sulfates. There you have a -2 apiece, so that's giving you a total of -4. It's lead 4, so that's +4, so it ends up electrically neutral. Crisscrossing the oxidation numbers is the easiest way to do that. So it asks us how many lead atoms. There's no subscript here for lead, so that's like having a 1 there. For the next question, N2O7, they are both non-metals, so that's telling you that it's going to be covalent, which means you're not going to need any Roman numerals. What you do have to pay attention to is whether you need prefixes or not. The prefixes go with the subscripts. This N2, 2 goes with di. The first element you never change the ending of, but you have to add a prefix if there is a subscript, so you would never actually start off mono here. So you get dinitrogen, 7 is hepta, So you get heptoxide. Sometimes you might see an A in here. Sometimes they leave it out. Either one is fine. Heptoxide or heptaoxide mean the same thing. The second element always gets a prefix no matter what, and it always ends in IDE when it is covalent. So that's what we get. Dinitrogen heptaoxide. Notice there is no charges. There's no crisscrossing. The prefixes go with the subscripts for that element. The next question down, it's giving us ammonium chloride. And is a blank, and you know that because blank, it says pick all that apply. So now when we look at this, it will help if you actually write out what ammonium chloride is. Ammonium, people forget about a lot because it's an oddball one. It has a positive 1 oxidation number. It is a polyatomic ion. You can get that from the polyatomic ion sheet. Chloride, ending in IDE, is giving you a hint that it's probably off of the periodic table. There are a couple of polyatomic ions that end in IDE. Most are ATE or ITE, but there's things like hydroxide, bisulfide, cyanide, azide, amide. There's a couple exceptions, but this one is just chlorine off the periodic table. It's as an anion. So when you cross those oxidation numbers, you get NH4Cl. Since there is a polyatomic ion in here, even though there's no metal, this is a polyatomic ion, so it is an ionic compound. So we know, well, you know what? I guess I shouldn't have done that yet because I didn't check the other part of it. We know this ionic compound part is right. And ionic compounds are also electrolytes, so that part is good so far too. Electrolytes are compounds that will conduct an electric current. So ionic compounds, you put them in water, they dissociate or deionize. It's basically saying they break apart into their ions, and that helps electric current flow through that solution. Now the other part of this, it does contain a polyatomic ion, so that part is good too. So this is one of the right answers. And it says, this other one it says is a salt. Salt is just a very generic term for an ionic compound. So if something is an electrolyte, it is an ionic compound, and it is also a salt. So that one's good. Now, it's not a covalent molecule. It does not contain a metal atom. That part is true, but it's still ionic because that's a polyatomic ion. Now, NH4Cl is not a base, and it does not contain ammonia. I know ammonia sounds similar to ammonium, but ammonia is NH3. For us, most of the time, bases end in OH. That's not always the case. You wouldn't really know for sure unless you do an experiment with it, but it definitely does not contain ammonia. So that one's out. All right, let's go on to the next one. CuSO4.5H2O. You should realize this is ionic. It has a polyatomic ion in there, SO4. Copper is also a metal. Now it ends up being a hydrate, but it's an ionic compound that is a hydrate. So what we want to do is find copper first on the periodic table. Copper is right here. You see how it could be a +1 or +2? So that's telling us we have to do a little more work with this. Now to figure this out, you always will know what the other part of that compound is. SO4 is sulfate. You find that on the polyatomic ion list. It's a -2. I know there's a 4 here, but that whole sulfate is the polyatomic ion. So you only have one of that sulfate group. We don't have parentheses with a number outside. So if this side is -2, the other side has to be +2. There's only one copper. So that whole +2 is coming from that one copper. So that's going to cross out those because they need Roman numerals. SO4 is sulfate. So right now, both of these are good. So we have to look at this part. 5 goes with penta. 4 is tetra. So we end up getting this. Copper 2 sulfate pentahydrate. When it's a hydrate, these coefficients out front, they get the same prefixes that we use for covalent compounds. Which the next one is. What is the name for capital NO? So this is a covalent compound, 2 nonmetals. So that means we're going to need some prefixes here. So there's no prefixes, so that one I can cross out right away. Now there is only one nitrogen, but you never start off with mono. So both of those are out, but we could just check this to make sure. So you have nitrogen. The second element, no matter what, gets a prefix. So you need the mono in there. And the second element, when it's covalent, always ends in IDE. So you get nitrogen monoxide. For number 7, NaClO. again, you should be able to pick out that that is an ionic compound because it has that ClO. That is a polyatomic ion. Now, again, first thing you do when you realize it's ionic, find sodium. Sodium does not have any numbers here, so it is not multivalent. You do not need to use Roman numerals or any of that kind of stuff. So we just get the name for Na, which is sodium, which they all have. ClO you would find on the polyatomic ion sheet, and it is hypochlorite. Now, a lot of times this hypo part throws people off. It's just a prefix for this polyatomic ion. There are a couple polyatomic ions that have chlorine and oxygen. So you have chlorite, hypochlorite. All right, so chlorite would be ClO2. Hypochlorite is ClO. Chlorate is ClO3. And then you have a perchlorate, which is ClO4. Right, so what they had to do is start making prefixes for those because there's so many options between those. Okay? So now we can jump down to the last one, MoCO3 with a 3 outside of the parentheses. Just a second to kick in. Okay. Now, when we find molybdenum on the periodic table, it has several different oxidation numbers. It looks like +2, +3, +4, +5, or +6. So we definitely have to figure out which one is which. So right away, I know those two are out because they don't have oxidation numbers, and this one's out because this is using a prefix, but it's not covalent. It has a polyatomic ion in there and a metal. So what we have to do, the only way you can figure this out is by breaking this apart. We know what carbonate is. It's -2, but there's 3 of them, so that's a -6. So this side has to be +6 to balance it out. So now what you get is molybdenum 6 carbonate. It's not the 3. What happens sometimes, people go a little fast and they see a 3 here and they say, oh, well, it must have been molybdenum 3 because I know you have to crisscross the oxidation numbers, but you can't do it like that. And the reason why is because we reduce these subscripts when we can. So if you're working with MO, that's a +6, carbonate, that's a -2. When you first crisscross, you get MO2, CO3, with a 6 outside, that 2 and that 6 reduced to a 1 and 3. So since we reduce these subscripts, you can't just look at this and say, oh, and uncrisscross the numbers and say that's it. You have to go through these steps to figure it out. All right, so that was the review for naming and bonding for the online practice test